So we'll start with SAS triangles. So that obviously stands for side, angle, side.
Yeah.
And what we'll do this as an example. So we want to construct the triangle ABC. So we put that onto my main screen here. So we've got this triangle here, and we want to construct it. Okay. So the first thing we want to do, well, I haven't got to do a sketch because I've got it here anyway. But first thing we do is and by the way, this would be with a protractor and a compass as well.
Yeah.
So let me get my compass. Now, needless to say, you should use a pencil with a compass, but I've got a pen. Should hang on, let's get a pencil. Sorry about that. There you go. Right. So
Yeah.
first thing we do, we draw 5 centimeter line. So that's going to do that. So that's going to do that like that. So we have this 40-degree angle. So what I'm going to do is got my protractor. I'm going to put that on A, where there is the 40-degree. Then I'm going to make a mark at 40 degrees, just there. And then you've got 4 centimeters. So what you can do then is just join A to that. This one's one of the ruler and compass ones. Obviously, I've only got to go to 4. And then I can join that C to B. So that's quite straightforward, I think. Does that all make sense there?
Yeah.
Yeah, there's no issue with that one. I mean, that's quite a straightforward one. Um, yeah, there's not a lot to that. Right. So I've got a few here that we could do, but I think that probably makes sense. Yeah.
Yeah.
I don't imagine there's any complexity with that really.
Yeah.
So what we'll do, let's look at the other side. The other one is ASA, because what we'll focus more on are the loci questions. Because
Okay.
loci is more where you're going to get marks, particularly in, well, I would say a numeracy exam, but of course they've moved everything around now. So let's say here we have, let's say we want to draw this triangle. Let's move this out of the way. So that's SAS. You've got a side, you've got an angle inside, then another side.
Yeah.
We can also have ASA.
Okay.
So you might have like an ASA triangle. Let's say we've got this one. So we want to construct PQR using a pencil and a protractor and a ruler,
Okay.
obviously. So this time you would draw 4.5 centimeters for PQ because that's your specified distance. And then it's 38 degrees above P. So I put my protractor again, center in the middle of the protractor on P. Then we always start measuring from 0. So that's on the inside of my protractor. So I'm going to stay on the inside. We go up to 38. Make a little mark with your pencil. And then what I'm going to do is I'm going to draw a line which goes through P and through that mark. It doesn't matter how long, and just make it better to make it longer, really. And then we do the same thing on Q, obviously anti-clockwise this time, and 70 degrees. Because can you see this time I would start measuring from the left-hand side,
Yeah.
and it would go to 70. And then we just join from Q to that new mark that we've made. And we want to leave all the lines in. You don't rub these bits out. And then you've got your triangle PQR. So this was 38 degrees. This was 70. So if I measure the missing angle, it should be, if I add up 70 and 38, we get 108. The angles of the triangle should add up to 180. So if I do 180, take away 108, that should give me the missing angle. 72, and if I measure this missing angle, should be somewhere in that ballpark. So I can see 70, and yeah, it's about 72. So that's how we would do an ASA. Is that okay?
Yeah. What's wrong?
Brilliant.
72.
Yeah, brilliant. It should be around 72. That's great. Yeah, so I've got 4 different ones here. I don't want to spend ages on those again. I think that's quite straightforward. We want to focus more on the loci. But then you also get ones with all 3 sides. That's one set. So all 3 sides is going to be with a ruler and a protractor only, because obviously there's no angle. So
Yeah.
this is now an SSS. So I'll do that over here. And I think one of these enough should be fine. We'll just look at the past paper ones on loci. So you've got your SSS triangle, that is all 3 sides. Because when we do congruent triangles, we'll see ASA, SSS, and what's the other one? SA, and yeah, there's also SAS. Well, no, there's ASA, SSS, and
S.
yeah, there's
SAS.
SAS the first one. Yeah, that's the first one. So SAS, ASA, and then SSS. You'll see all of those again when we
Yeah.
do congruent triangles. So this one's got 5 centimeters, 6 centimeters, and 6 centimeters. So we draw the baseline first, which is 6 centimeters. And the line AB is 5 centimeters. I'm going to open my protractor up to 5. So the way I do that is I put the point on 0 on my ruler, like that. And then I put the pencil on 5. So it's there, like that.
Yeah.
And then what I do, I'm going to put my compass point on A, because it's the line AB that is 5 centimeters. And I'm going to draw an arc. So that's not showing up on the screen. Let me do that again. So I'm going to draw an arc. Probably better if I use a pen. So I've got my arc.
Yeah.
Then I open up to 6 centimeters. And I'm going to put my compass point on C and draw an arc. Like that. And then I can join up A to where the lines, where the arcs intersect, and B with where the arcs intersect. And then I can see this is my triangle ABC. And you can measure them. You can measure it to verify. That's 5 centimeters, 6 centimeters, and 6 centimeters. Is that okay?
600 meters. 600 meters. Yeah. Good.
That's all fine. Brilliant. Right, so suppose there is another one. I mean, there's, yeah, 2 sides non-included angle. Did we do that one? The 2 sides are non-included angle. That would be the, suppose, well, there is a mixed one as well. I suppose there's this one. So we'll go with this one. This is a bit of a mix. So we've got 2 sides and a non-included angle. So that would be one like this. So what I've done there, I've just sketched it, obviously.
Mm-hmm.
So for this one, we would probably need to use a mix of both techniques. So the first thing I would do is draw my line XZ because that is the base. So we have XZ and that is 5 centimeters. Like that. Then I've got this 72-degree angle on above the line XZ on the right. So I'm going to get my protractor and I'm going to center it on Z, which is the right side of the line. And obviously I need to go clockwise because I can see it's 72 degrees above. The 0 is on the outside, so I stay on the outside. So we go to 72, which is there. And then you draw a line from Z through that point. Like that. But then I can see the line XY is 7 centimeters. So I'm going to open my protractor up to 7 centimeters, which is like that. Then I'm going to put my compass point on X and then draw an arc. Like that. And then where the arc and the line intersect, I join from there to X. Like that. And I've got the line X. I've got the triangle, sorry, X, Y, Z. So that was 72. That was 7. And this was 5. Does that make sense then?
Yeah.
So that one's maybe a bit of a trickier one they can ask. Because that does combine both of them together. So if I give you maybe 2 of these to do. So we've got these 2. So we've got these 2 here. And a way of checking whether we're right. So the way to check, let's get my pen. So what we could do with a check, if you have a go at these and then measure the line, oh, I can see that's, yeah, that's going to be equilateral. Yeah, it's going to be basically equilateral, but we could do it anyway. So if we measure the line XY, once you've done it, and then with the other one, you can measure the line YZ, and then we'll see how close we are.
Okay.
Okay, so if I've got that, I'll have a go as well. Yeah, I think for the first one, you need to have a lot of space.
Yeah.
Yeah, I've definitely not drawn them accurately by my sketch. Have you done the first one?
Yeah.
Yeah, brilliant. So I get about 3 centimeters, I think. Do you get that?
Yeah.
Yeah, thereabouts. Just checking it with this. Yeah, this is the sine rule. I'm just gonna check if I've got that's 41. In fact, actually, I've got the answers. So I'll just look at that. But yeah, we get about 3 centimeters for the first draw. 3.18 thereabouts.
Yeah,
Yeah,
I got
oh,
like 3.2.
yeah. I'm doing it as accurate this time. Yeah, about 3.18. There we go. Brilliant. Have you done the second one?
Almost.
No problem. I'm just still doing it myself.
Yeah, I've done it.
That's brilliant. So for that one, it's about 6.75
Yeah.
thereabouts. So we happy with that? I haven't done it on here, but are you happy with that? Yeah,
Yeah.
brilliant. Right, so
I got 6.8.
I mean, that's brilliant. There we go. 6.8 thereabouts. So 6.75 is me using a calculation to work it out anyway, so that's fine. So there's drawing equilateral triangles. So you could be asked to draw an equilateral triangle. So I'll just one sec. So you could be asked to draw an equilateral triangle with sides of, say, 10 centimeters. So if that were the case, I would firstly draw the 10 centimeter baseline. I don't know, I'm using the pen. That's not even from 10. There we go. So let's say it's a triangle ABC and I want an equilateral triangle. So you've got your line AB, and then to draw an equilateral triangle, you just put your compass point on one end of the line and you draw an arc. It doesn't matter how big you make it as long as it's more than halfway along. When you draw an
Yeah.
arc, and then you leave your compass as it is, and then you put the compass point on the other end of the line,
Hmm.
and you draw an arc, and then you join up A to where the lines intersect,
Yeah.
and then B. Actually, this is an isosceles triangle anyway. This is isosceles. Yeah, well, actually, this is nice. Let me do that again. Sorry. No, if you want an equilateral triangle, sorry, you have to open it all the way from one end to the other.
Okay. Yeah.
Because what we want in there, you want a 60. That's not going to be a 60, obviously. So we do that, and then you put
Yeah.
your compass on B, and then you join up. So you would join A
Yeah.
to where the lines meet, or the arcs meet, and then you would join
Hmm.
B to where the arcs meet. And then you can see you've got a triangle where the interior angles are all 60. So that is going to be equilateral. Does that sort of make sense then?
Yeah.
Brilliant. So let's have a look at some other questions here. So this is more for loci. So that first question here is just what we did. So when I did it with, yeah, so that's just what we did before. So you would have your 10 centimeters, open it to 6, draw the arc, open it to 8, draw the arc, and then join them up. That's just question one. Question, so in fact, let me look at the different loci things they could ask you. We'll go through those because have you done loci in class much?
No, not yet.
That's fine. We'll go through loci. It's quite straightforward. It's really the same. I mean, that's constructing triangles. There's not much difference really. Um, and equidistant, fixed point, line equidistant, and you've got to bisect as well. So effectively with loci, this is what you've got to do, or this is what you've got to be able to do. So it sounds a lot harder than it is, but it's just the way they've written it. So you've got to be able to do points that are equidistant from a fixed point. So that just means they're the same distance from a fixed point.
Yeah.
Equidistant from two fixed points, again, well, all that is really, if it's two fixed points, it's just the middle. If it's two lines, what we call the angle bisector. So I'll just
Yeah.
draw them up. So with two fixed points, it's going to be the perpendicular bisector. And with two lines, it's the angle bisector. And then solving problems involving intersecting loci in two dimensions, that's just sort of numeracy questions. So we'll do to start with, let's have a look at some questions. Let's say, right, so the obvious one is if I have to do, let's say I want to construct, the locus of points is just a set of points. So all that means is like a line where that condition is met. So if I want to construct the locus of points 6 centimeters from the point P, let me get some printer paper, that'd be best. Let's imagine I had the point P, I'll just put it here. The locus of points equidistant, that just means equally distant from P, is just going to be a circle. So I open up my compass to 6 centimeters. So that is there. Then I put my compass point on P, and I just draw the circle. So I imagine that's very easy. Does that sort of make sense there?
Yeah.
I just draw the circle on if I can. I'm going to hash that, sorry. So that'll be really straightforward.
Mhm.
Let's look. So, right. So let's say we have this question. I might actually still have. I've still got this actually. I can do it on my screen. If I can get this working again. Oh, I still got this actually. That's quite good. Let's put that on there. So let's say I want to construct the locus of points equidistant from X and Y. So what we would do here is you'd firstly join up X and Y like that.
Mhm.
And then what we're going to want to do is draw an arc. So let me find my compass, should be in the tools, maths tools, not those. Might be on smartboard. Got my compass on here, I might have smart. Got this, actually, this might be the one. So can we just get this up? Don't really want to use that. Shouldn't have to sign into this. There we go. Right, so I can join up the points X and Y. Then you get your compass. So there we go. So I'm gonna sugar. So put your compass point on X, like that. You open up the compass so that it is more than halfway along the line. And then you draw the arc.
Yep.
And then I'm going to leave it as open as it is now. And I'm going to go over to Y. And then I draw another arc. Then you can see where the arcs intersect. So here and here, we can join up with a straight line,
Yep.
like that.
Yeah.
And what I have drawn, that line that I've just drawn, is the locus of points equidistant from X and Y, because it is the same distance from X as it is from Y.
Okay. Yeah.
Yeah, so that's, again, it's the same sort of idea as what we did earlier, but that's what it is. And what we've actually drawn is the perpendicular bisector. So you've really drawn a 90-degree angle.
Mhm.
Does that sort of
Yeah.
make sense there?
Yeah.
Um, so what would be good is if we look at, make a new slide here. So let's look at, right, let me just move this. So we'll look at doing an angle bisector as well. There you go. Can you see my screen okay? Yeah,
Yeah.
it's okay. Let's plug it in. There you go. Right, so let's say I want the locus of points equidistant to lines. So this is the angle bisector. So if we think about where this would be, so I've got this situation. The line where all of the points are equally distant from this line and this line is going to be this line here. Does that sort of make sense?
Yeah.
Because that is exactly halfway between the line AB and the line AC.
Mhm.
Okay. So to do that accurately, you get your compass again. Put the compass point on A. I'm gonna open up the compass. Doesn't matter how, doesn't really matter how much. I'm gonna draw an arc. And you leave it at that same level. I just control Z that. There you go. Leave it. So I don't want to draw anymore. Right, that's that. Leave it at that same level, and you draw another arc on the line AB, like that. Then you take the compass away, and you put it onto one of the arcs you've just made. And then it, again, you can open it up a bit more if you want, but I normally leave it at the same amount. Draw another arc. And then we move it to the other arc that we made, and we're going to draw another arc. Okay. And then
Yeah.
you just join A to where those arcs intersect.
Okay. Yeah.
And then you've got your angle bisector. Okay. So a way that we can test that is if, what I'll say is, you could have a question like this, where it is, let's say, construct, oh, sugar, could be, it's a pen that works. Could be, I don't need a fancy pen, let me get an old pen. Construct an angle of, let's say, um, 30 degrees. Let's say we want an angle of 30 degrees. So to do this, if I first, so let's say the angle could be, I don't know, CAB. So to do this, firstly, we would construct the angle of 60, and then you would bisect it. So if I think about what that would look like, if I do a little sketch, it would be something like this. So you've got CAB. You want that to be 30 degrees. So the first thing I can do is draw the line AB. And then we want to do what we did earlier, where we did the 60-degree angle, the equilateral triangle. So if I get my compass, put it on A, we're going to open up the track. We're going to open it up all the way along. It doesn't have to be all the way along, actually. Yeah, it doesn't have to be all the way along here because I've done it too big. Let's do more like that. Okay, so we draw an arc. So we've gone from one end of the line to the other. We draw the arc, and then we do the same thing on the other end of the line, like that. And then can you see that we have now drawn a 60-degree angle? So I've got ABC. And this is 60 degrees. Okay. So then all I've got to do is bisect that angle that I've just drawn. So I'm going to get my compass back. Let's get a different one here. You put your compass on A, we open it up. Doesn't matter how far. We draw an arc. Then we're going to do the same thing on the line AC. You put your compass onto one of the arcs that you just made, like where it hits the line. And you draw another arc. Then leaving it at the same level, we go to the other arc. And you want another arc now that will intersect that one. And then where the two arcs intersect, you can join A2. And then you've got this angle here, which is 30 degrees.
Yeah.
Which I can measure. We can see that is pretty much bang on 30 degrees.
Yeah.
Is that okay?
Mm-hmm.
And similarly, you might get a question where you have to do a 45 degree. So it could be that, let's say this is construct. Get a pen. I'll just CAB again. Let's say we want to construct the angle CAB, which is 45 degrees. So just to show what that would look like, we would have something like that, CAB, where this is 40 degrees. So that means you'd want a 90-degree angle at A, and then you could just bisect it, not 40 degrees, 45 degrees. So we'd have 90-degree angle at A, and then you'd bisect it. Okay?
Okay. Yeah.
So let's say I've been given the line AB there. So that's the line AB. So what I'm going to do first is I want a 90-degree angle to the line A. So if I get my compass, if I put the compass point on A, what I'm trying to do is, so I don't need to actually open it up all the way to B. I can open it up to, doesn't matter really, as long as I leave it at that level. So then I can draw an arc to where I've opened my compass to. Did not mean to make that a circle. And then I can open up. So if I leave it at that same level, I'm going to extend the line that I've drawn. So the line AB, I'm just going to extend it over to the left. Just get red. Oh, let me change colors. Let me change color. Right. There you go. So leaving my compass at the same level, I'm going to draw an arc on the other side. Let me just again, it's not letting me draw the arc. Let me open that up to a different angle. And let me start this again. Hang on. Delete it. So that's my line AB. Sorry about that.
Okay.
So what I can do, if I get my compass, put it on A, open it up, I'm going to draw an arc first. This is what I missed, sorry. We draw an arc first, and then I'm going to extend the line over to the left. Like that. Leaving my compass at the same level, I'm going to draw another arc on the other side of A, like that. And then what I do is I put my compass point on one of the arcs that I've made. I need to ensure that the compass now is open to more than halfway along this little line that I've made between the two marks. Then I draw an arc.
Mm-hmm.
And I do the same, again, leaving the compass at the same level. Do the same on the other arc. Join those up. And then you can see that you've got the perpendicular bisector that go, or the perpendicular line that will go through A. If I just join up the two arcs that I've made. Like that.
Yeah.
So now we should see that we have a 90-degree angle here.
Yeah.
So what I'm going to do is I need to chop that in half. I need to bisect it.
Okay.
So if I put my compass point on A, and then I'm going to draw an arc, and then another arc, leaving my compass at the same level on the line above. Then I put my compass on one of the arcs I've made. I draw another arc. Put it on the other arc that I made earlier, and draw another arc. And then I join A to the intersection of the two arcs that I've just made.
Uh-huh.
And that is going to be 45 degrees.
Really? Yeah. Okay.
Is that okay?
Yeah.
And obviously I could just label C up here. Brilliant. So let's look at another question. 3 centimeters on the line PQ. So this is a bit of a strange one. This isn't one that comes up. Maybe it does come up, but it doesn't come up as abstract as this. So let's say I want the locus of points equidistant from 2 points. Delete all that. I'm going to leave that in, actually. I can save it then. Right, so I want the locus of points equidistant from the line PQ. Not
Yeah.
equidistant, I want it 3 centimeters from that line. So what we would do here is obviously, so firstly I would get my ruler. So it has to be 3 centimeters from this line. So obviously we could see that would be like 3 centimeters above, 3 centimeters below.
Okay.
But then at P, it would actually be a semicircle. Because if I
Uh,
want all the points 3 centimeters from P, it would be a circle all the way around P.
yeah.
So obviously, on the left side, you'd have to have a semicircle. And similarly at Q, you
With
would
Q,
need a
yeah.
semicircle with radius of 3.
It can be anywhere in between.
Exactly, it
Yeah.
could be anywhere in between. But above and below, it just needs to be 3 centimeters.
Yeah.
Hang on, let's change to inches. Don't want that. There we go. So let me, so if we have a go at that. So firstly, I'll just get my ruler. Can I snap it 90 degrees? No, okay, I have to do that. So that's 270. So I measure 3 centimeters. That is there. I can do a little mark. 3 centimeters below. Actually, I'm going to say it's not right. But then again, can't read this ruler properly. 0. That is a really hard to read ruler. That's not a neat ruler at all because it's got the big markings away from the numbers.
Yeah.
That's awkward. Let me change that. Can I change the settings on that ruler? Um, Properties. Yeah, I do not like that ruler at all. That is awkward, right? So it's an incredibly awkward ruler. It doesn't really matter though, right? So I'll make do. So 270. So 3 on this insane ruler is here. Just let me
That's,
draw that.
yeah. That's good.
Yeah, it's just a really poor ruler. So that's going to be the 0. So I do that, and then 3 centimeters below. Obviously, that'll be this where the 6 is.
Yeah. I don't know.
Just there. I don't know why they've put the big lines
Gap.
halfway between. That is really stupid. So then what we do, we just draw the straight line parts. So that's going to be here. I can't use it as a ruler. I can't use a ruler. Let me just do it with the line tool. Then you open your compass up to 3 centimeters. And then you're going to draw the semicircle. So it would be, I just moved it off the screen. Obviously, I'm a little bit off because I'm on the screen, but we draw the semicircle there. And similarly, you would draw the semicircle on Q, like that. So sorry, it's a little bit messy, but that would be the
Huh?
locus of points that are 3 centimeters in the line PQ. Because if
Yeah.
I'm on that line, if I'm here, I'm 3 centimeters um,
P.
from P, and then that is technically a line PQ as well. So we just, yeah, so I'm 3 centimeters the line from PQ there. If I'm here, I'm 3 centimeters from the line PQ wherever I
Yeah.
am. Does that sort of make sense there?
Yeah.
Brilliant. So we'll look at some other ones. So the typical sort of question would be, it's like a GCSE one. So this would be a GCSE one here. So we want to indicate the region that is inside the rectangle. Extend the page. So extend it all the way, but okay. Right, so indicate the region that is inside A, B, C, D and is closer to point C than to point B, closer to the line AD to the line AB, more than 1 centimeter from D. Okay, so, and it's inside the rectangle only. So if I do a little sketch of it first, it's got to be closer to C than it has to B. So can you see that would be these points?
Yeah.
So if it's close to B and to C, it would have to be anything in that bit. That would be that all of the points in there would be closer to C
And
than they would be to B.
yeah.
I go to those. Um, so obviously we need the perpendicular bisector there, and this all this stuff. Um, Closer to AD, the line AD and the line AB.
Yeah.
So all of the points that are equidistant from AD and AB would be these points. So if I'm closer to AD, you'd have to be in this bit.
Yeah.
Okay. So I can already see it taking shape really. If I do the perpendicular bisector there, angle bisector there. So far, I would need to be in both of those regions. I would need to be in here.
Yeah.
And then
And
more than 1 centimeter from the point D. Well, if I open up my ruler, if I open my compass to 1 centimeter,
then draw a
then it would be an arc. It's going to be a circle, right? One
yeah.
centimeter, but it's only inside the rectangle. And it's got to be more than 1 centimeter. So it would have to be outside that circle, which leaves
So
me with
yeah.
this little bit. So
Yeah.
then all that remains is to do it accurately. So to do the perpendicular bisector of BC, you get my compass. I'm gonna move this down a bit. So we'll put the compass point on if I want the perpendicular bisector. It's really awkward to do it at an angle. So I'll open up my compass to there. Okay, it's gone off the screen. That's really annoying. So well, actually, if we want the bisector, we open up to more than halfway. Something like that. Draw an arc. Then we leave it at the same level or the same amount of open. Put the compass point onto C. Draw another arc. Okay. Up there. Okay. So then what we do, and really, if it's closer to point C, it should be a dotted line. So, if it's closer, there should be a dotted one. Dotted lines I want on that. Right. Okay. Does that make sense?
Yeah. Yeah.
Right. And then so closer to AD than AB. So again, we do compass on A. It doesn't matter how far open I make it. I draw an arc. And then I'm going to draw another arc then, leaving it at the same level of open on the line AD. We
Yeah.
then put the compass onto one of the arcs that we've made. And you can open it up a bit more if you want to now, as long as you leave it at this new level. And we draw an arc. Oh, sugar. And then you go to the other arc that was made, and you draw an arc. Nope, I haven't opened. I didn't do it far enough earlier. I think so. Let's just put the image above the protractor. That's really stupid. Let's put the image above. That's really silly to put the image above it. Let me put that back. Order that needs to go at the back, really. Yeah, that's better. There we go. So I've just about seen where they intersect. Then I draw my line through A. So again with a dotted line, like that. Is that okay?
Yeah.
Right, so then it also needs to be, so far we can see we're in the bottom left. It also has to be more than 1 centimeter from the point D. So if I open up my compass, so I'll get my ruler. So we want this at 1 centimeter. So again, this is an absolutely terrible um, device. And also it's going to be very small because that is just how I got it. 1 centimeter is there. Put it onto D, and then we're going to draw. It should again be a dotted line. There you go. More than 1 centimeter from D. So if we look at where that is, I'll shade it in. Highlight would be the best to shade in, but it doesn't matter. I'll just do it like this. So it's more than 1 centimeter from D, so it's outside of that semicircle. That's a really bad color to use. Let's use black again. It's outside of that circle. And then it would be, again, it's a pencil. Pencil's better. Well, highlight is the best. So it's outside of there. It needs to be closer to C. So it's going to be on the bottom half of the rectangle. And then it needs to be closer to AD than AB. So it's the bottom side of the diagonal line. So it's going to be in
Hmm.
here.
Yeah.
Does that make sense there?
Yeah.
Brilliant. So you see, is that actually what I had earlier? I did it. Yeah, that's exactly what it is. Although, here we go. That's fine. Right, so that's the sort of question you would see in an exam on it. So if we look at some loci questions, I think I've got a few here. So we'll look at some tricky ones again. So you can see with these ones here, these are Maths Genie. These are good to print off, just have a go, and you can get all
Yeah.
the answers. I'll show you can get the answers for these. We'll look at the GCSE ones though. B and yeah, so you can see all of the answers here. So it's worth printing them off and just seeing if you can get these. I'm sure you can. But let's look at some. There we go. This is an actual loci question. So look at this. You do a new page. That's better. I get the full space now. Right, so we've got a scale drawn of a garden. Scale is 1 centimeter to 2 meters. Now the problem with that is I don't know how to scale my screen is. 1 centimeter to 2 meters. I think that's probably acceptable. Um, let's make it a bit bigger. There we go. So a tree is going to be planted. It must be more than 4 meters from the patio. So obviously, according to this scale, that's got to be 8 centimeters.
Yeah.
So what we can say, we know it's 1 centimeter equals 2 meters. So 4 meters is going to be 8 centimeters. And we know 6 meters is going to be 3 centimeters. So 6 meters is 3 centimeters. Is that okay?
Yeah.
Now it needs to be more than 4 meters from the patio. So the patio is here. So it's got to be more than 4 meters away from there. I would say it's really, that's a bit dodgy actually, but I would say it's referring to this line of the patio.
Yeah.
Although that is a little bit unclear because it's like a block. Yeah, but I would say it has to be the right hand side of the patio.
Yeah.
The tree must be more than 6 meters from the pond. Well, that's quite easy. You just have to have a circle around the pond and be
Hmm.
outside of that. So the first thing, so we're saying uh,
Is
more
it?
than, sorry, go on.
No, it's fine.
I know what you mean. It's not clear because it's a block, but You need to be more than 4 meters from the patio. So if I think of that as the right side of it, then it would need to be 4 meters there. So I could just draw a line in this case. I could just say, again, do a dotted line. Don't know if they'd really care if you did the angle bisector there. Because it needs to be, because I suppose if I'm anywhere on that line, I'm exactly 4 meters away from the right-hand line. Now for the pond, if I open up the compass to 6 centimeters, put that on the pond, and then draw the arc. Well, it's a circle, really. I mean, the way I've drawn it doesn't really work.
Aren't you supposed to
Three
do it?
centimeters.
Yeah.
Yeah,
And
sorry.
same with your line. Shouldn't it be 2 centimeters?
That's true. Sorry about that. Yeah, you did. Sorry about that. Elliot, thank you for reminding me there.
Yeah.
Yeah, that makes more sense. Yeah, because it's 3 centimeters is 6 meters. Yeah. So really, it doesn't outside of the because again, it's inside. It doesn't really these. Oh, sugar. These bits here don't really matter. That's not letting me delete them. But yeah, the bits outside of the rectangle don't matter.
Yeah.
So it's more than 4 meters in the patio, so it's going to be out here on this side. And then it is
And
more than 6 meters in the pond.
yeah.
It's going to be outside that circle. So then we can just shade it. If I get my highlighter. Obviously, in the exam, we just shade it in pencil.
Yeah.
It's going to be out there. Is that okay?
Yeah.
Brilliant. So let me get the answers there for 10. 10, yeah, you can see it there. Same thing.
Yeah.
Uh, close to a B, B, C. Let's have a look at this one. Right, so we've got a scale drawing of a room. So we've got a scale drawing of a room. The chair is going to be placed so closer to AB than to BC. So that's going to be the close to, yeah. So that's going to be the bisector, and it would be up here. And then it needs to be less than 14 meters from D. So if D is there, if I imagine this is the circle, actually with that would be impossible. So it must be that it's like that. And then it would be in this bit. Does that sort of make sense there? Obviously, I haven't actually drawn it accurately yet.
Yeah. Yeah. Right. Yeah.
So, so the first thing, if we want to do the perpendicular bisector of ABC, that's going to be where we can get the points that are closer to AB than BC. So if we
Yeah.
get our protractor, we don't need a ruler for this. We put it onto B because we're looking at AB and BC. Open the protractor, we draw an arc. Then we do the same thing on the other line. So this time the line AB.
Mhm.
Then you put your protractor on one of the arcs that you've made. and then you draw another arc. And again, you can open up the protractor a bit more now if you want to. So it's going to draw another arc. And then similarly on the other arc that you just made,
Mhm.
I've drawn that really weirdly, but there we go. And then you just join up A or B, sorry, to those two where the arcs intersect.
Okay, yeah.
That's your angle bisector. So at present, it needs to be the top part of that triangle. And then if we look at it's 1 centimeter to 2 meters. So we can say, right, 1 centimeter to 2 meters. It's 14 meters from D, so that's going to be 7 centimeters. So let's see if this actually works on the screen. So I get my ruler. So there we go. Going to open this up to 7 centimeters. Not seven, yeah, 7 centimeters like that. Put it onto D, and then we just draw the arc or the circle. I'm just going to do it as a solid line. Oh, I've barely got it working. Based on the scale that I've done, that barely works. Can you see it's only just...
Yeah.
That's my own mistake for the scale that I've done. I should have, I tell you what, I should have made this a bit smaller. So let me do that again. That's all the way. Not smaller, bigger. So let me just... Can't think it's bigger or smaller. Make it, no, make it smaller. Right. There you go, that makes sense. So we can see now that it would have to be uh, so it is close to AB, so it's the top bit, and then it is less than 14 meters from D, so it would have to be inside. So
Yeah.
there, is that okay?
Yeah.
Brilliant. So there isn't a lot more to loci, really. So there's like this one point is 300 meters. We can have a go at this one. This is a good question. So, right, so a bit smaller. So we've got A, B, and C are 3 points on the map. 1 centimeter is 100 meters. So again, let me see if that is a sensible scale on here. That isn't sensible. That's better. Right, so point P is 300 meters from A, and it is equidistant from B and C. So if I think about a sketch again, so right, that's 3 centimeters. So yeah, because 1 centimeter is 100 meters here.
Yeah.
So P is 300 meters from A. So I know like, that's about 3 centimeters. So I know P is somewhere on that circle. So I've drawn that really badly, but
Yeah.
P is
No,
somewhere
yeah.
on that circle. And it is equidistant from B and C. So B and C, if I think about the perpendicular bisector, be like that. So the line that
Yeah.
I've just drawn, the dotted line, those points are all equal from B, equally distant from B to B and C.
Beautiful.
So then it is equidistant from equidistant. Oh, so there we go. We can see where the 2 points would be.
Yeah.
It's going to be here, and it's going to be here. And in fact, here I shouldn't be using dotted lines anyway. Should be using solid lines here because it is actually
Mhm.
inclusive. So it's not greater than or less than, it's actually equal to. So I've got that circle. So P, if this is 300
Yeah.
meters, then P is somewhere on that circle. And then it also needs to be on this line that I've drawn. And can you see it would be this point and this point?
Put it back there. Yeah.
Brilliant. So then to actually do the drawing, so I need my compass open to 3 centimeters. I can get it there. And then we put that onto A, draw the circle. Then we want the perpendicular bisector of BC. So if I join up B and C,
Hmm.
so join up B and C, and then if I can actually move this protractor, now the protractor's stuck. There we go. So what you can do, you put your compass onto B, you open it up so that it's more than halfway along the line.
Yeah.
It doesn't have to be all the way along, so as long as it's more than halfway. Draw an arc, and then leaving it at the same level, we put it on B, on C, sorry. You draw an arc,
Yeah.
and then where
Uh,
the arcs meet, you've got your perpendicular bisector. So perpendicular
yeah.
just means at right angles. So then we join up the intersections of those arcs,
Where
like
they
that.
both meet the circle.
Yeah, exactly. And then where the points meet the circle, those will be the possible positions of P. So it would be here and here. Those would be your possible positions of P.
Uh-huh.
Is that okay?
Yeah.
So really, there's not a lot else they can ask you in terms of loci and constructions. So what I'll say is, if I send over the this booklet here, you
Okay.
could print it off and just have a go at the questions.
Yeah.
Although, let me see Mass DIY, there might be some questions in here as well. Yeah, no, it's not. Yeah, they haven't actually got anything on loci, but that's fine. You got the Mass Genie questions, so I'll send those over. You print them off, you can have a go. Probably got some Mass Swatch ones here as well. Did your school use Mass Swatch, by the way?
I'm not quite sure.
Yeah, you'd know about that. Do you use Haggerty Maths or Maths DIY? Not Maths DIY, My
Math
Maths?
DIY.
Do you use My Maths at all?
Yeah,
Yeah, there you go.
we do it a lesson every 2 weeks, aren't we?
Oh, that's good. There you go. So, yeah, because there's all this stuff here. Constructing perpendiculars with angles, loci. Yeah, I can send you these as well. That'll be good. And then as long as you can do those, should be fine. Okay.
Yeah. Okay.
Okay. Right. Brilliant. So enjoy the rest of your week now. Have you got a
Thank
test?
you.
Have you got a test coming up at any point?
I have a mock coming up on um 2 weeks.
Right.
I
That's what I
think
can.
it's the March.
Right. I see. I can maybe send some past papers over or something like that. But you know where to get all the past papers anyway, so that'll be fine.
Yeah.
Okay. All right. Bye now.
Thanks.